Hello. Hello. Right, this is greenhouse gases. It's part of GCSE chemistry. I was just checking if my microphone was on there at the top. Looks like it's working. Okay, so let me just turn. I don't think you need to see me, so I'm going to turn my camera off. Okay, so you can see the screen. Yeah, that's what you need to concentrate a bit more on. That's sort of me looking at the screen. Okay, so it's part of GCSE chemistry. So learning objectives. So we're going to look at a description of the natural enhanced greenhouse effect. An explanation of how greenhouse gases absorb infrared radiation and radiate it back to Earth, and a discussion of how humans are increasing the strength of the greenhouse effect. Okay, well, first of all, ask a question. I was looking at the moon last night for a telescope, actually, to confirm it does have craters. So why does the moon have craters that are millions of years old, I should say, while very few can be seen from Earth? So the moon does not have an atmosphere or weather to change the surface. So if a meteorite or an asteroid hits the moon, okay, and forms a crater, then it will be there forever. There's no weather, there's no rain or wind to change that surface. Okay, so it'll just stay there forever. Okay, whereas on the Earth, that you can see obviously the clouds and it rains and there's wind. So, for example, there was a meteorite hit the Earth, then it would get weathered away. So you do get meteorite craters on Earth. They do exist, but there's not as many, anywhere near as many as you see on the moon. Okay, because it's got weather and an atmosphere. So we're just going to go over what the atmosphere is. We're getting to greenhouse gases because they're obviously part of the atmosphere. So to be clear, the atmosphere is a layer of gas that surrounds the Earth. Okay, it's split into these different layers: troposphere, stratosphere, mesosphere, thermosphere, and exosphere. We only really need to be worried about the troposphere. Sometimes we talk about the stratosphere and a bit about the ozone, but nothing about a GCSE really above that. But it's interesting anyway to look at all the different layers. So all the weather occurs in the lowest 10 kilometers. Okay, so all the planes, that sort of holiday planes you might have flown in, commercial planes, they're in the troposphere. Sometimes you get very sort of high-flying military aircraft sort of going up just above, but most planes people have been in the lower 10 kilometers, and all the weather happens down here. So troposphere means overturning sphere, okay, because lots of things go on in it. The stratosphere is quite calm, really, compared to the troposphere. Okay, so what is it made of? Start off with. So mostly you've got nitrogen mostly. Surprisingly, only 21% oxygen, so not as much oxygen as you might think there is. The 1% argon, also known for being in light bulbs, okay, because argon's very inert, so it doesn't react with anything. Okay, and yeah, it doesn't really do much in our atmosphere, to be honest. It's just kind of left over from the early Earth, which you might see in another lesson. Carbon dioxide, so this is the one people talk about, but it's actually only about 0.04% of the air. So you might think of it as this is the air, as the atmosphere. When we talk about them, we go the air. Okay. Yeah, the one we talk about, carbon dioxide, is actually quite a small percentage, but it can do quite a lot of things. Okay. And this is other trace gases like water vapor. Okay. And so look, I'm still recording. Yes, sorry, it's flashed up. So other trace gases like water vapor, less than 1%. That depends where you are on the Earth. Okay. So if you're somewhere tropical, okay, that you are, you can get more water vapor, like rainforest, than somewhere like a desert, okay, where there's less water vapor. So we don't often talk about that too much because it just depends where you are, that one. Okay, so we really do need the atmosphere because so the atmosphere does a lot of things for us other than provide us with oxygen. So yeah, other than giving us oxygen to breathe, that actually keeps the Earth warm. Because without the atmosphere, the average temperature would be minus 15 degrees all over the Earth, and it wouldn't be very habitable for us to live. Well, yeah, other than having no oxygen, the temperature would make it very difficult for us to live on the planet, any life to exist. Okay, so on the moon, you can see it doesn't have an atmosphere. So humans, we need to take our own oxygen with us. So we need to have a spacesuit with an oxygen backpack, okay, to provide us with the oxygen that we'd need. And obviously, it's very cold on the moon as well, so you need a heated suit as well, so it's very cold without an atmosphere. Okay, so we're going to talk about different types of greenhouse effect, because it's actually split into two, really. So there's the natural greenhouse effect. I was going to see, I've included something. Yeah, go back, sorry. The natural greenhouse effect, because I'm going to do an overview, then I'm going to go into more detail. That's what I was going to tell you. So the natural greenhouse effect. So this is natural. Okay, that means it's there by nature. Humans didn't cause this, is what I'm trying to say. Because in our atmosphere, there naturally is some carbon dioxide. There's some methane, and sometimes there's other H2O that says water vapor. So these three gases act as greenhouse gases. So they keep the Earth warm. So radiation from the sun, so in the form of infrared and light comes in, okay, and the greenhouse gases stop some of the radiation from escaping. So that's a general picture. They stop some of it escaping. Some of it does escape back to space. We don't keep all of the radiation in, but some of it is kept in by the greenhouse gases. They could keep the Earth warm. Okay, but so that's a natural one. That's one we need. Okay, that's by nature that occurs. But humans are putting greenhouse gases into the atmosphere, which we'll go into more detail a bit later, and actually causing less radiation or less heat to escape into space. So more is being kept in the planet. So that's the general overview of a human enhanced greenhouse effect. So there is a natural greenhouse effect, but humans are enhancing it. They're making it kind of stronger. So we'll go into more detail now. But first of all, in your own sort of time, okay, because obviously use a video, pause and things like that, pause it and fill in the missing words here. So it's sort of like a stop point. Okay, I put in here so you can sort of stop and complete the sentences, okay? And then there's the answers if you've got stuck. Okay, let's go into a bit more detail now then. Yeah, we need to go a bit more detail now. We have an overview. That's kind of what's going on. So sort of that summary, but we'll look in a bit more detail, okay? So greenhouse gases, so carbon dioxide, methane, so CH4, and water, H2O, what they actually do is they actually absorb infrared or thermal radiation. So infrared is thermal radiation, and radiate it back to the Earth, making it warmer. Okay, so the sun emits radiation of all different wavelengths. So infrared, X-rays, gamma rays, radio, UV, X-ray, yeah, so gamma, obviously visible, microwave, radio, and all of the EM spectrum, but we're really focusing on infrared at the moment. Okay, so the greenhouse gases actually absorb, so like this is what I'm trying to talk to you about. They actually absorb some of the radiation coming from the sun and they re-radiate it back to the Earth. Okay, so sometimes some of the light also just bounces off the Earth and they take that and they sort of absorb it and re-radiate it. Okay, so that's the more precise definition of what is happening. Okay, so they're actually trapping the heat by doing this. They're absorbing the radiation, the infrared, and they are re-radiating it back. Okay, so I've written lots of notes. You look at your own time describing it in more detail next to it of what I've said, because it's a bit of a more advanced thing to think about, this one. And again, to have a pause, so and copy and complete this one. So this was a bit more complicated, so I'm going to talk through it. So yeah, some of the radiation from the sun is reflected by the atmosphere back into space. Some radiation passes through the atmosphere and is reflected off the surface. Greenhouse gases in the atmosphere absorb some of the radiation, increasing the thermal store of the atmosphere. Okay, thermal store of the atmosphere. So that was on, okay, thermal store of the atmosphere. The greenhouse gases emit the radiation back to Earth, creating a warming effect. Three greenhouse gases are methane, carbon dioxide, and water vapor. Humans are adding carbon dioxide to the atmosphere by burning fossil fuels for electricity and transport. Okay, so before we think, why is it called the greenhouse effect? So why might we call that? So people have thought about it in the past when they named it, as similar to when you walk into a greenhouse on a sunny day. So if you walk into a greenhouse on a sunny day, you know that it's very hot in there. Okay, so everyone's growing plants themselves or knows someone that grows plants. They know that when you walk in, it's very warm. Okay, because the rays of light from the sun come in, they bounce off the floor, they bounce off the vegetation, so the plants inside. And actually, some of this radiation loses energy. Okay, and it bounces off. It's got not enough, most of it's not got enough energy to get out again. So the infrared radiation, which has got less energy than the visible, is actually trapped inside the greenhouse. Okay, so you're probably thinking, yeah, it's not exactly like the atmosphere, is it? So that's what we're going to sort of discuss. It's not exactly like the atmosphere, but it's a good way of thinking about it. Okay, so obviously makes it warmer. Oh, another way of thinking about it is a blanket. Okay, so when you wrap a blanket around yourself, you feel warmer. I mean, I'm talking about a normal blanket, not a heated one, just a normal blanket. So what actually is happening there is the heat from your body is trapped by the blanket. Okay, your body emits infrared radiation, which the blanket absorbs and radiates back to the blanket. So think about that. That's more similar in some ways, isn't it? But not in others to that greenhouse. Okay, so that's why, yeah, it's not, both of these are not perfect. Okay, but perfect models. But it makes you think a bit because I don't really see that. Sometimes it's like a blanket around the earth. Some people said. But what I want to do then, so it'd be really good. Let me just zoom out of this so I can write on things. Okay, so which model is best for the greenhouse effect? The greenhouse or a blanket? Write down your reasoning. So I've given it a template here, the blanket model and the greenhouse model, so advantages and disadvantages. So I'd like you sort of to think about what are the advantages and disadvantages of why these two things. One is like the greenhouse effect, one is like the other. So let's start off. Okay, so the blanket model, an advantage with why it is like the atmosphere. Okay, so obviously look at, so when you wrap yourself in a blanket, it's your own heat that's getting trapped. So is that like or unlike the atmosphere? So yeah, the Earth doesn't radiate its own heat, does it? Like it reflects it. So you can write that down. So maybe it doesn't matter if you think of disadvantage or advantage first. Okay, so a blanket. Okay, a blanket re-radiates heat from your body as your body emits infrared, so that's heat. Infrared. The Earth does not, that's a disadvantage, it's not like the Earth. The Earth does not emit its own heat, it comes from the sun, okay? Okay. Advantage, why it is like that. So the greenhouse gases absorb infrared radiation and re-radiate it back to the Earth. A blanket is similar as it re-radiates infrared radiation from your body. Okay. When we make a model, it's never a perfect, it's never perfect like the thing. So you know about a model in science. I've seen a lot of exam questions with this sort of thing about evaluating models. So I've included it here, lots of exam questions. So and they can ask you about a lot of things, but why it's unlike or like a model. So the greenhouse effect advantages. So it's clear, isn't it? So let's radiation in like the atmosphere. So it's clear. I mean, it's not radiating its own heat there, is it? So it's the same sort of thing. Okay, radiation in. You can say warms up the interior, the inside, like the atmosphere. Disadvantage. Only kind of there's one. The reason why it made me think about doing this was there is one disadvantage of greenhouse effect. So in a greenhouse, the infrared radiation is trapped by the glass. The atmosphere does, sorry, the greenhouse gas, to be more precise, the greenhouse gases do not trap the infrared radiation, they re-radiate it. So we've got something for everything there. Atmosphere, got a P in there. Okay, right. So yeah, that's a question that may be asked in the exam about comparing models at school. Right, okay. So here's some example questions. So this is what I put in a text box. So why are greenhouse gases essential to life? So greenhouse gases, only one mark. Remember, it's not about that. It's not oxygen. It's not a greenhouse gas. So it's not about breathing. Okay. So greenhouse gases keep the earth warm enough. Right. It's more about them keeping warm. Okay. And then this one. Well, what a good question this would be. Okay, to get in an exam about just naming greenhouse. So for example, greenhouse gases, carbon dioxide, methane, and water vapor. Water vapor, what people forget, but water vapor does act as a greenhouse gas. Okay. Right. So let's have a look at this question. So the Earth's early atmosphere was different to the Earth's atmosphere today. Scientists think the Earth's early atmosphere was like the atmosphere found on Venus today. So table 7 shows the amounts of carbon dioxide and oxygen in the atmosphere of Venus and Earth today. So gas carbon dioxide percentage in Venus's atmosphere 96.5. Okay, percentage in Earth's atmosphere 0.04, what we saw before. Oxygen in Venus, none, probably traces, but which might as well be none. Percentage in Earth 20.95, yeah, 21%, rounded up. The percentage of carbon dioxide and oxygen have changed from Earth's early atmosphere to Earth's atmosphere today. So explain the processes that led to these changes. So this is a very, very common question. Okay, that's brought up. So explain the process. So I'm going to say that the temperature of Venus is extremely, extremely hot as well. Okay, so carbon dioxide is an extreme greenhouse effect occurring on that planet. Okay, so the changes. So Earth early atmosphere. So when Earth, oh, get that bit big. Can put that down. So when Earth first formed, the atmosphere was mostly provided by volcanoes, which let out carbon dioxide, water vapor, well, actually water vapor and nitrogen. Okay, over time, the water vapor cooled down and condensed to form the oceans. The carbon dioxide in Earth's atmosphere dissolved in the oceans. This lowered the amount of carbon dioxide. So algae, so they're small plants, algae evolved and started photosynthesizing This took more carbon dioxide out of the atmosphere and put oxygen, so that's why we've got so much oxygen, because of plants, back into the atmosphere. So yeah, it's the photosynthesis that's important here, because there's no living things on Venus. Okay, so on Venus there are no oceans, bit of bonus content for you, and no life, no plants to give oxygen. So yeah, it just kind of stays the same as it was when it first formed, really. So that's kind of just, it kind of just stays there. So I'm just going to finish this recording now. Okay, thank you for listening, and goodbye.